Hello everyone. Today we will learn composite functions. What is a composite function? It's a function that made of other functions where the output of one is the input to the other. Let's look at these functions fx and gx. If I ask you to find f of g2, what you're going to do? Well, you're going to take the number 2, input it into the function g, and then you are going to get the output and input it into f. So let's do that. So basically you're going to calculate g2, which is equal to 2 squared plus 4, that's equal to 8. And then you are going to come here and substitute 8 in the function f, which is going to be 8 plus 1, that's equal to 9. What we got is actually f g2 and can be written as f of g2. So composition is where you take one function and put it inside of the other. And what we get is an entirely new function. So we can use again f of gx or f gx as an alternate notation. Okay, now let's try to do the question we have here. Okay, they want us to find f of g, g of f of f, and g of g for these two functions, and then find the domain of the composite function we get. Let's see how we are going to do that. We'll start with f of g. So f of gx, I'm going to replace gx by the function gx. So it's going to be f x squared plus 4. Now I'm going to go to f, replace x by x squared plus 4, which is going to be x squared plus 4, and then plus 1. Simplify it, it's going to be x squared plus 5. Let's move on to the next, g fx. We're doing the opposite. We're going to take x plus 1, which is fx, substitute x here by x plus 1, which is going to be x plus 1 squared plus 4. To simplify, it's going to be x squared plus 2x plus 1 plus 4. That's equal to x squared plus 2x plus 5. Then f of f, f of x plus 1, take x plus 1, substitute it into here. And finally, I'll tell you gx, substitute x squared plus 4 in here. Simplify. Now guys, we need to find the domain of these composite functions. Well, let's think about f of g. For any number I will plug into this function, it has first to go through gx, okay? And then f can take care of it. Same, if I will use an input here, fx should deal with it first, and then gx will take care of it. So in order to find the domain of the composite function, first we need to find the domain of the input, and then the domain of the new function. Okay, so now let's try to find the domain of the fx and gx first. Well, the domain of fx is all real numbers. The domain of gx is all real numbers. Now the domain of each one of these composite functions is all real numbers. So the domain of all these is going to be all real numbers. Now for this question, we need to find again f of g, g of f of f, and g of g and their domain. Well, let's start with f of f. Let's start with f of gx actually first. So f 2 over x. Now go ahead and substitute x by 2 over x. Then try to simplify. It's going to be 2 minus x over x. And let me remind you of this. We will multiply by x and x to have common denominator. And finally will be 3x over 2 minus x. Now to find the domain, first we need to tell what is the domain of this. We need to find what can make the denominator equal to 0. So x cannot be equal to 2. So the domain, well, for the composite function here is all real numbers but not 2. Now remember, you need first to find the domain of gx, the input function. Well, the domain of gx is all real numbers but not 0. So that means if I want to tell what is the domain of f of g, it will be all real numbers but not 0 or 2. Because you cannot use 0 because in the beginning you were unable to use it. Okay. Next, f g of fx. You will go and put 3 over x minus 1 in gx, and that's going to be equal to 2x 2x minus 1 over 3. That's basically 2x minus 2 over 3. Now, one more time, the domain here is going to be all real numbers. But what about the domain of the input function fx? Well, the domain of fx was all real numbers but not 1. Right? So now we can say that the domain of the composite function is all real numbers but not 1. Okay, guys? Now, let's move on and try to find f of f and g of g. So, f of f of fx, and that's going to be equal to f of 3 over x minus 1. Go back, 3 over x minus 1 minus 1. Try to simplify by multiplying the numerator and denominator by x minus 1. So it's going to be 3 over 3 minus x plus 1 over x minus 1. You can take this up, and this is going to be equal to 3x minus 1 over negative x plus 4. Now, to tell the domain, we need first to find the domain of the input function, which we mentioned that it's all real numbers but not 1. The domain of the composite function is all real numbers but not 4. So the domain of this function will be all real numbers except 1 and 4. Okay. Now last thing is going to be g of g, which is equal g of 2 over x That's equal 2 over 2 over x. That's going to be equal to 2x over 2, which is equal to x. The domain here is all real numbers, but the domain of gx was all real numbers but not 0. So finally, the domain of g of gx will be all real numbers but not 0. Let's move on to the next question. X squared plus 1 and square root of x minus 1. Let's start by finding the domain of each one of these. Well, this is a polynomial, all real numbers. For this one, whatever inside the root should be greater than or equal to 0. X should be greater than or equal to 1, so the domain is from 1 to infinity. Now, we can find the composite functions. F of g, f of gx is f of a square root of x minus 1. Then we can go here. Which is x. So we know that this is a polynomial, so the domain is all real numbers. And since for gx it's from 0 to infinity, so that means the domain of f of gx is going to be 0 to infinity. Now, what about g of fx? G of x squared plus 1, which is going to be equal to square root x squared plus 1 minus 1. And that's going to be a square root of x squared, which is equal absolute value of x. Now we know that the domain is all real numbers. The domain of f of x is all real numbers, so the domain of g f x is going to be all real numbers from negative infinity to infinity. Then f of fx, f of x squared plus 1, and again x squared plus 1 squared plus 1. That's going to be x to the power of 4 plus 2x squared plus 1 plus 1. One more time, domain of this is all real numbers. The domain of fx is all real numbers, so the domain of f of fx will be also all real numbers. Last thing is g of g. So g of gx will be equal to g of a square root of x minus 1. That's going to be equal to square root of x minus 1 minus 1. You cannot simplify it more, but we need to tell the domain. So we know that the domain here is from 1 to infinity. Let's try to find the domain of whatever inside the square root. It should be a square root of x minus 1 greater than or equal to 0. Square both sides. So x is greater than or equal to 2. So the domain will be this. From 2 to infinity here. Here from 1 to infinity. So the domain of g of gx will be equal to 2 to infinity. Next question. X minus 5 over x plus 1 and x plus 2 over x minus 3. So again, the domain here is all real numbers except negative 1. Domain here is all real numbers except the 3. So f of gx is f of x plus 2 over x minus 3. Now go to the equation and substitute x by x plus 2 over x minus 3. And then minus 5 plus 1. Try to simplify by multiplying the numerator and denominator by x minus 3 here, and same here. That's going to make the numerator x plus 2 minus 5 x minus 3 over x minus 3. Here x plus 2 plus x minus 3 over x minus 3. Now these two can cross out each other, and we are going to get okay. Now we need to find the domain. So the domain here is 2x minus 1 equals 0, 2x equal 1, and x equal 1/2. So x cannot be equal to 1/2. So the domain of this will be all real numbers except 1/2. But what about gx? It's all real numbers but not 3. So the domain of f of g will be all real numbers except 1/2 and 3. Now let's try to find g of f. G of x minus 5 over x plus 1, which is going to be equal to x minus 5 over x plus 1 plus 2, x minus 5 over x plus 1 minus 3. Now simplifying, it will be x minus 5 plus 2 x plus 1 over x plus 1, x minus 5 minus 3 x plus 1 over x plus 1. Crossing out these two, that's going to make this x minus 5 plus 2x plus 2 over x minus 5 minus 3x minus 3, which is going to be equal to 3x minus 3 over negative 2x minus 8. Now the domain will be all real numbers except negative 4. It's basically negative 2x minus 8 equals 0. That's the reason behind it. And the domain of f of x was all real numbers except negative 1. So the domain of g of f is going to be all real numbers except negative 4 and negative 1. Now guys, it's your turn to find f of f and g of g. I will leave it for you. Let me know if you have any question. Goodbye.